Bismillahirrahmanirrahim. My name is Hammad and I will explain this topic of Raphson today. Okay. In this method, we solve nonlinear equations for their roots finding, and we do it like an equation x square. Oops, sorry for that. X square plus 2x 3x plus 2 equals to 0. Okay. Just let us first draw a graph of this equation, and that graph cuts the x-axis at some arbitrary point, and let us take an arbitrary point away somewhere on the curve like here, and drop a perpendicular to the x-axis like this. Name this point as xi. Okay, now what we will do, we will find the tangent of the curve at this point and project this tangent to the x-axis, and wherever it cuts we name it as xi plus 1 point on x-axis, and a perpendicular drawn up straight up to the curve, and there this point is named as f of xi plus 1, pretty logical, and the other point is f of xi. And now we will draw a tangent to this from this point as the derivative of the curve, and now we will see that uh, how this point on x-axis, where the tangent cuts, it's converging to a root here. No? So this proves the this method's usefulness. No? So we can use it as a programmable. So the equation by the derivation of Newton-Raphson method we get. Now what we will do, that or the Newton guided, he derived an equation, a relation like this: xn equals to xn minus 1 minus f of xi n minus 1 upon derivative of the function at xn minus 1 point. And this equation is a straight line equation. One can easily judge from its stature, or actually its derivative taken as 0. One can easily. Oops, sorry. Let's just try to remove it. No. Okay, just leave it. Let us take this thing to MATLAB and try to program this method. Since it is an iterative method, so we prefer programming it, because who will do so many iterations for a really big problem. Okay. Uh, in this MATLAB window, here I have wrote a function of my equation, and I have you can see that I have two output variables in this function and one input text. What I do, I calculate in this line the function of x and store it in variable p1 and the derivative of this function in d. So I have calculated this derivative manually and input it as an equation here. This gives me the two desired outputs, as we will see we require in the code. Here in the code, the A stands for the x n minus a, as in our original terminologies, and here the C is the accent that we use for the converging root. No? So these terms are we have used as a replacement. This error variable is what it does calculate the difference of our function at x and from 0. Since in these root finding algorithms, the error is the difference of 0 or difference from 0, no? Of ordinate. As less this difference is, the error is less and our root is more perfect. This tolerance, it defines how much the error could be. So I have if minus 4, you can if minus 5, minus 6. Now this is amazing. This thing, this tick, uh, as we see here in line number 8, followed by a talk at line number 17. These two calculate the time taken by this while loop. This while loop is actually the Newton-Raphson code running for and finding the root as in several iterations. Now, it okay. Now let me explain what is happening in this code. Uh, as you can see in the number 10, there is I record two variables, uh, fa and dfa, with the function p1 and as an input argument a, and this gives okay. And in the line number 11, I wrote the Newton-Raphson's formula as derived earlier. It used to calculate the root, converging root. In next line we have the FC. This FC we get from the root that we recently calculated from Newton-Raphson formula. This let us calculate the error. Let us check how far are we from our original result. So this is helpful in determining the uh, ending of algorithm or program. Uh, in line number 13, we do what we do. We put a equal to c. That is when the root is not up to the accuracy, we do iterate. So this is the process of iteration. We put that new root into the a in the previous root and do the iterations again and again, and till we get to a good converged value. Okay. In the next line, in line number 14, we have iteration variable updated. This tells us how many iterations it has taken up till now. In line number 15, we update the error variable with the absolute error from 0. Actually, the error is the function of uh, function at c or xn that that we are taking. So as the loop ends, we plot the error since we were recording the error as a vector, and we can see that now if I run this code, we can see that how fast this method was. It calculated to the desired route in so much fast. It has very drastic slope, and we can see how less the iteration it is. Only 3 iteration it took, as we can see in the workspace variable I. Only 3 iteration it took for it to converge to this value of root. We have seen earlier the root value. C value is the root. Okay, that's all for today. Thank you for watching. You can find me on this email for any query or this MATLAB code. Thank you.